we're going to talk about parallel and perpendicular lines. So theorem 3-8, if two lines are parallel to the same line, then they are parallel to each other. Okay? So L and M are parallel. M and L are parallel. Therefore, L and N are parallel, right? So L is parallel to M, N is parallel to M, so therefore they both have to be parallel to each other. Theorem 3-9, in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So L is perpendicular to M, and L is perpendicular to N, therefore M and L are parallel. Okay? The key there is in the same plane. Okay, so here's our problem 1. A carpenter plans to install a molding on the sides and the top of a doorway. The carpenter cuts the ends of the top piece and one end of each side pieces at 45-degree angles as shown. Will the side pieces of the molding be parallel? Okay, so notice here that this is 45, 45, 45, and 45. So what we're doing is we're looking at sliding this piece in here, this piece in here. Is this edge going to be parallel to this one? Well, what is this angle going to be up here? Well, I have here, I'm just going to kind of draw it in here on the side here. There's my simple drawing. 45, 45, 45, and 45. Well, what is this whole angle here? Well, this whole angle is 90. This whole angle is 90. So, yes, the sides of the molding will be parallel because the sides are perpendicular to the same edge. Okay? Perpendicular transversal theorem. In a plane, if a line is perpendicular to one of two parallel lines, then it is also perpendicular to the other, which kind of makes sense, right? So if I know these two are parallel, right, and I know M is perpendicular to L, now I also know that L is perpendicular to N, right, because these are parallel. Okay, so we're going to write up a proof here. So it's given C is perpendicular to B, so I know that. B is perpendicular to D, there we go, and D is perpendicular to A. Prove that C is going to be perpendicular to A. Okay, so the first thing I'm going to do is write my two-column proof, so statement, reason, and I'm going to rewrite my given. I always want to rewrite my given here. So C is perpendicular to B, B perpendicular to D, and D is perpendicular to A. That's given. Okay, so that's important to know. Now, okay, well, I see here when I drew up my symbology on my diagram, I noticed that I have a perpendicular line here and a perpendicular symbol here. Well, what does that make with C and D? Well, it makes them parallel. So C is parallel to D because lines perpendicular to the same line are parallel. Okay, so I'm going to kind of shorthand. So I now know that these are parallel lines. Okay, well, that's good to know, right? So, but now I know that these are parallel. What do I know about A and B? Well, A and B are also parallel, right? A is parallel to B. Well, why? Well, it's the exact same reason, right? So now I know that these are parallel. I'm going to go ahead and erase this. I'm just going to put parallel here. So now I have that these are parallel, right? Well, do I now know that C is perpendicular to A? So C is perpendicular to A because if lines are parallel and one line is perpendicular to a transversal, then the other line is perpendicular. Right? So that's the last theorem we just talked about. You could write the theorem number there. Okay, so what do clowns do after April 30th? Matrix. What do you get when you add 50 female pigs and 50 male deer? $100,000. All right, so that's looking at parallel and perpendicular lines.